Hello AP Chemistry and welcome to 16.8 where we tie together Ka and Kb and put some quantitative backing to the concept of conjugate acid and base pairs, right? So first of all, make sure you know that relationship, right? And I feel like you probably already picked up on that already, right? But Ka times Kb equals Kw, which means that pKa plus pKb based on log properties equals 14, right? Which is pKw, right? Okay, so when we are using these, right, this gives a, again, quantitative aspect to the fact that weak acids, conjugates, tend to be basic, right? Which is something we've been saying since the beginning of the chapter, right? So for example, if we look here, right, HNO3 is a strong acid, right? Meaning it dissociates completely, which means that its K value, if we were to assign it one, approaches infinity, right? And if Ka times Kb must equal Kw and Ka approaches infinity, then Kb, or the tendency of nitrate to react with water, must approach zero, right? Does that make sense, right? That's just how that is, right? Which means that Kb, in this case, approaches zero, which means nitrate has no tendency to undergo hydrolysis in the presence of water to produce hydroxide ion, right? And then likewise, right, that changes for every other species, right? So then if we look at HF, which is considered a weak acid with a Ka of 10 to the negative 4-ish, right? Since they're tied together by Kw, right, we know that F minus must be somewhere along the lines of 10 to the negative 10, or in this case 10 to the negative 11-ish, right? Does that make sense? Because that fills out that 10 to the negative 14th, right? And then obviously the weaker our acid gets, right, if we have 10 to the negative 11th, right, eventually we end up with something that is significantly basic in the carbonate ion, right, with a 10 to the negative 4, meaning that carbonate ion definitely has a tendency to react with water, right, to form hydroxide ion, resulting in a basic solution, right? And then obviously the hydroxide and the oxide ion. Okay, so again, like it says in the outline, the derivation is useful to know, right? Because that's really just an application of Hess's law, like we talked about back in chapter 5. But really, like Ka times by Kb equals Kw. And I think that's easy to understand just from understanding pH equations also. All right, now, what that also means is that this problem that we did previously could also be answered from a Ka perspective, right? So for example, we could use this, right, our H plus, right, and if we wanted to, if we knew the Ka, right, we could even work from the perspective of the ammonium, right? Does that make sense? Which means that basically every single problem could be solved from two different directions. Here, we're not going to solve any problems, but we're just going to make sure we understand, right, the relationship between Ka and Kb. So I would like to know which of these anions has the largest Kb, right? And I have NO2 as an option. I have PO4 3-, and I have N3-, right, the azide ion. So if I want to know which has the largest Kb, what do I need to know? Right, I need to know the respective Ka of the acid from which they came, yes? The acid from which they came, which means that NO2 is the product of what? Right, the acid from which it came would be HNO2. The acid from which this came would be, right, HPO4 2-, and this would have come from HN3, right? Now, thinking about those respective hydrolysis reactions, right, we're really looking for what are the Ka values for these, right? Turns out the Ka value for HNO2 happens to be 4.5 E-4, right? HN3 is 1.9 E-5, and HPO4. Now, again, if we think about the parent acid, this, and then this, and then this, and then we eventually end up at PO4 3-, right? What Ka are we looking for? Right, this would be Ka1, Ka2, Ka3, right? So we are looking for Ka3, which happens to be 4.2 E-13. So if I'm looking for the largest Kb, it's going to be the one with the smallest Ka, yes? The one with the smallest Ka, which means that one. All right, good, does that make sense? The other one is just, can you do some math? All right, thank you for listening. Thank you for listening, be good, and I will see you soon.